In this video, we're going to look at using trigonometric functions. In particular, we'll use those trigonometric functions to find missing side lengths of triangles, as well as apply the trigonometric functions to various real-world applications that involve right triangles. In this example, we want to find the unknown sides of the triangle. This triangle has a 30-degree angle labeled for us, and the side opposite that angle is length 7. The other two sides are labeled A and C, and those are the lengths that we would like to find. To find the side labeled A, what we observe is that that side is the adjacent side to our 30-degree angle. We're also given a side of length 7, which is opposite 30 degrees. And so we are given the side opposite our angle, and we want the side adjacent to our angle. And so we want a trig ratio here that involves the opposite and adjacent sides. And the tangent function will work for that. So the tangent of 30 degrees from this triangle will be 7 over A. And we'd like to solve this equation for A. Now 30 degrees is one of those angles that we should be able to determine the trig functions for. That specifically, we should know how to find them for 30, 60, and 45 degrees. In this case, we might know the tangent of 30 degrees, or we might not. However, we should know that the tangent of 30 degrees is the sine of 30 degrees divided by the cosine of 30 degrees. Sine of 30 degrees is 1/2, and the cosine of 30 degrees is the square root of 3 over 2. And so we obtain that 1 over square root of 3 is equal to 7 over A. At this point, we can cross multiply to see that 1 times A, or A, is equal to 7 times the square root of 3. And so the side labeled A has length 7 square root 3. The other side of the triangle is the side labeled C. That's the hypotenuse of our triangle, and we're given still the side opposite 30 degrees. And so to find C, we need to use a trig function that involves the side opposite an angle and the hypotenuse, and that, of course, would be the sine function. So we know that the sine of 30 degrees is going to be the opposite over the hypotenuse, 7 over C. We know that the sine of 30 degrees is 1/2. That is one of the angles whose trig values we should know. And so 1/2 equals 7 over C. Cross multiplication gives 7 equals 2 times, or C equals 2 times 7, or 14. So C will equal 14 units. In this particular example, we were just simply given a triangle and asked to find the unknown sides. There was no context given. The sides of the triangle and the angles of the triangle had no real-world meaning. However, right triangle trigonometry is most often used in real-life examples when we're trying to find heights of objects, distances between objects, or other things of that nature. And so for the rest of this video, we're going to look at a couple different applications that involve right triangle trigonometry. Many real-world examples involving right triangle trigonometry involve either an angle of elevation or an angle of depression. So we quickly review these two concepts here. An angle of elevation occurs when someone is looking up at something from a fixed position. The angle of elevation is measured between the horizontal and the line of sight. For example, if someone is standing on the ground and looking at the top of a tree, the horizontal is the ground, and the line of sight is the line from the person to the top of the tree. And the angle between the horizontal and the line of sight to the tree would be the angle of elevation. On the other hand, the angle of depression will occur when you are looking down at something. And again, it is the angle between the horizontal and the line of sight. So for example, if you are in a plane flying in the air and you look down at an object on the ground, the angle of depression is the angle between the horizontal, that is the path of the plane in the sky, and the line of sight from you down to that object that you're looking at. Here is a simple graphic that elevates these two concepts. Again, notice the angle of elevation, since it's being taken from the ground, is the angle between the horizontal, or the ground, and the line of sight to the top of the tower. The angle of depression would be the angle between the horizontal from the top of the tower down to the point on the ground. In this example, a person walks to a point 30 feet from the base of a tree and measure the angle of elevation to the top of the tree to be 57 degrees. We'd like to determine the height of the tree, or how tall the tree is, from this information. In order to do this, we first start by drawing a right triangle that represents our situation. We'll represent our tree with a vertical line and the ground with the horizontal line. This ground we know will be a length 30 feet, as that is how far the person is standing away from the tree. And our person is over here at the end of this 30-foot side. And the line of sight up to the top of the tree is going to be the hypotenuse of our right triangle. And we're told that this angle of elevation here is 57 degrees. And so this is the picture that represents our scenario here. The person is standing 30 feet from the tree. The angle of elevation is 57 degrees. And we'd like to find the height of our tree, which we could call h for height. So here we have this angle of 57 degrees. We know the adjacent side and would like to find the opposite side. And so the adjacent and opposite sides are both involved with the tangent function. And so we're going to compute the tangent of 57 degrees. And that will be h divided by 30, the opposite side over the adjacent side. We can multiply both sides of this equation by 30, and we get 30 times the tangent of 57 degrees is equal to h. 57 degrees is not one of the standard angles whose trig functions we should be able to evaluate by hand, and so we have no choice here but to use a calculator. And when doing this, we get that h is approximately equal to 46.2 feet. Now, one thing that is incredibly important here is that when you do this calculation on your calculator, you have your calculator in degree mode. And the reason is simple. The 57 that we're taking the tangent of is 57 degrees, not 57 radians. If your calculator is in radian mode, it will actually take the tangent of an angle measuring 57 radians, which is a different angle, and when you multiply that by 30, you'll get a very different answer. I believe that it's something around negative 40. And so if you get a very odd answer like that, double check that to see if your calculator is in degree mode, which is what it should be in order to calculate this appropriately. The correct height, though, is this, the 46.2 feet, and that's the height of the tree. In this example, we have a ladder resting against a building, making a 5 pi over 12 radian angle with the ground. The top of the ladder reaches a point on the building that's 50 feet above the ground, and we'd like to determine the length of the ladder. Again, the best bet here is to start with a picture of our situation. So we have our ground, we have our building, and our ladder is leaning something like this. And we know that this angle here is 5 pi over 12 radians. So we'll go ahead and label that. We know the building on this side is 50 feet because the ladder reaches 50 feet above the ground. And we want the length of the ladder, which we might call L. So looking at this diagram, we see that we know the opposite side of our angle, and we want the hypotenuse. And so this suggests that we should use the sine of our angle, 5 pi over 12. So the sine of 5 pi over 12 will be 50 divided by the length of the ladder, L. We could solve this equation for L, first by multiplying both sides by L. And then dividing by the sine of 5 pi over 12. And again, 5 pi over 12, like the previous example, is an angle that we don't know the trig values for off the top of our heads. And so we'll use a calculator here to get 51.76 feet. So our length of the ladder is just under 52 feet. Notice that in this case, your calculator should be in radian mode because the angle here, 5 pi over 12, is given in radians. If your calculator is in degree mode and you enter 50 over sine 5 pi over 12, you'll get a very different answer.